Now on my side, I would like to show to you power efficiency. During the marketing presentation, you have clear understanding that the WBA6 is definitely designed to run on some battery power application. So during this presentation right now, I would like to go back to some figures. But the idea is not to go back in details all the different low power mode figures, but really to show to you how you can evaluate and measure yourself thanks to our efficient and affordable ecosystem. First, WBA6 from documentation's figures. From slide point of view, so you will get a lot of information. So WBA6 power consumption. So this is pretty clear as any of our STM32 microcontroller. We are offering a different set of power node that allow to adjust your application to the right needs. And at the end, that will make your application really efficient in terms of power efficiency. So you will retrieve the common domain and modes that you are using on any STM32 microcontroller, so the run, the sleep, the stop mode, the standby. Good to notice here that the stop 2 is back on WBA6. So typically, if you have an application which is quite demanding in terms of peripheral that you need to wake up very often to do some application, maybe stop 2 will be more efficient. But as we are dealing with an RF chipset, and so you are designing as end customer an RF application, the mode we are all looking for is the lowest mode that still allow to sustain some RF activity and between RF activity to go down to sleep mode. And this mode is a standby mode that allow to reach 1.25 microhertz. That means if we consider a BLE application, because I'm more BLE stuff, but you will see that with my colleague Petr later on, you will have some ZigBee expert and Matter expert. If we consider a BLE application, so a beacon typically, that means I will start to advertise at some specific interval. So when I will advertise, I will burst, okay? I will consume some milliamp because I'm transmitting, and then I will go back to low power mode. And the low power mode that still allow to sustain the RF without switching it off is the standby. So between RF interval, I will consume 1.25 microamp. So this is from pure slide set. Now, what remain your let's say your reference is the datasheet. And let me open the datasheet. To open the datasheet, the efficient way WBA6 datasheet. Let me open the datasheet, and right in the datasheet, you will find a lot of information, and the sections we are looking for is the electric characteristic, especially the operation condition. In this section, this is where you will find all the information related to the current in stop 2, pending to the voltage, to the temperature. So this is where you will find the characterization. Now, good to notice that if we look at the first table of this section, there is now part of the datasheet, the current, so a sleep current, corresponding to a real use case. And the real use case considered here is based on a BLE application. We have considered a basic peripheral, which is advertising some data with the lowest power mode possible, the standby. And if we advertise 31 bytes every 1.28 seconds at 0 dBm, datasheet will tell us we should be around 13 microamp. Of course, this will depend at the end about potential temperature. It could be a bit variant pending to the path as well, but this is the target. Back to the slides. So this is from the pure figures from datasheet and from slides. Now, what I want to show you is how to move from those datasheet figures to some real power consumptions measure. And to do this, I will use a sample code which is part of our Cube ecosystem. I will use the BLE power peripheral, which is part, again, if you remember from the past session, you have the STM32WBA package, right? Part of it, you have project. Select the right board, which is STMicroelectronics. Application, BLE, and this is where I will find the BLE power peripheral. Again, IR, cube, and so on. So the code is there. I'm using IR. By the way, this code, on top of being part of the package, is documented as well on the wiki page. So all the steps I will show right now are documented over our wiki page. So if I go back again to our wiki page, hopefully this should be now, as you understand, your reference as well. There are a lot of information inside. So you will find typically some information about some BLE features. Okay, you can Google, but you can go to our wiki page to understand how the pairing security works and so on, how the EATT encryption advertising works and so on. But okay, back to my focus. It's related to the power consumption. There is a section dedicated where we are documented this code example, so power consumption energy. So there are brief description what the code is doing, how to interface the board to the power tool, and at the end, okay, how the code behave, what are the settings, and what the value you are expecting to find. So everything is documented. That's the point. So that means on my desk, I will have still my Nucleo WBA6, where I will have to flash for this BLE power peripheral. And I will use, okay, maybe at home, at work, you have some quite complex DC power analyzer, which are very nice, but that are quite expensive. I will use this ST-Link V3 power that allow to do some real accurate measurement, and that is, let's say, below $100, so far away compared to a complex DC power analyzer, but again, which allow to do some very accurate measures. And I will have to plug this one to the WBA6, where here I will have the BLE power peripheral, and here I will have my ST-Link V3 power that I will use and connect to my laptop, and I will use the power monitor tool. And the idea is to be able to retrieve the figures on the datasheet. Now, before moving and jumping into the code I'm using, this one, the BLE power peripheral, is the one as a reference to do some power measurement. But we'll have to do a bit of modification inside to really fit and meet the datasheet condition. So typically, first modification, I need to advertise at 1.28 seconds. I need to update the advertising payload to 31 bytes, so the maximum legacy, and I have to enable the full RAM retention. And this will be the way to meet and fit the datasheet condition. So this is our reference and the one to be used. So first of all, I will have to first find a USB cable, connect my board, and I will have to flash for this BLE power peripheral. So let's flash it. The BLE power peripheral is indeed the one which is a mode designed to do some power measurement, because inside we disable the LED access, we disable all IO access as much as possible. But in all our code example, P2P server, heart rate, the low power mode is enabled as well. But in order to play with, we have as well some LED blinking, some IO management activities that lead to some extra power consumption. But in all the code, at the end, can get the same power efficiency. The only point is that in this one, we disable as much as possible all the peripheral used. Okay. So I flash my board. So inside I have now here the power peripheral, and I will have to interface through the ST-Link. You will find inside the wiki page how to plug the ST-Link V3 power the board. So you will have to remove this jumper. So basically, you will put the output there. We will have to put the ground to the ground of the board. And for very high accuracy as well, the aux on the board need to be plugged here. But again, this is something documented over the meeting. So this is for the setup. Of course, now I have to plug my STMicroelectronics power. And to open the ST-Link V3, the STM32 monitor power, tool, which is quite very efficient tool. So let me open. Right, here we are. So I will have to select the right COM port. I will have to select the highest frequency, and I will acquire all the time. My setup is indeed, I will do some measurement at 3.3, and I start the acquisition. Okay, what we can observe here? We can observe that we have some peak which correspond to the advertising extension almost every 1.28 seconds, which is indeed the software setup. Now, let me stop. So I have my advertising burst, and I want to see what is the overall average. So between each advertising, I'm moving to standby. So let me select this time frame period. So the tool is building back the sequence, and then I will ask to what is the power average here, show the report, and you can see that, okay, I'm even far from datasheet. Okay, because here first I've got a golden sample. This is the one I'm using. And maybe the temperature condition, I'm not at 25 right now. And okay, I've got some very accurate and very powerful measurement. So thanks to the tool, we have been able to replicate easily the datasheet measurement. And you can replicate all measurement. So as takeaway, what we have shown here, based on existing sample code, so the BLE power peripheral sample code, which is documented over the wiki page, and using ST ecosystem affordable materials, so the ST-Link V3 power that I guess so you are using today, and the associated cube monitor power, we have been able to replicate the figures from the datasheet, which is a huge step. So this is the setup that you can use at your own to do your own measurement and evaluation in order to understand what your overall application will consume. So thanks for listening to me. Now we'll move to the OTA part with my colleague Alan.